Good afternoon. I'm Commissioner Tony O'Donnell from the Maryland Public Service Commission. Thank you for joining the inaugural Nuclear Energy Partnership webinar. This webinar is being recorded and will be available on our website in the near future. As a co-chair of the partnership, along with Commissioner Tim Echols, who's going to introduce himself in a second, I'm pleased to kick off this effort with NARUC and the U.S. Department of Energy. In March of 2021, NARUC formally launched this 5-year nuclear energy partnership with the support from the DOE Office of Nuclear Energy, and we greatly appreciate that support. The partnership includes commissioners and commission staff representing 20 states and territories, with that number sure to grow. Through this educational partnership, NARUC provides opportunities for state public service commissions and commission staff to better understand the barriers and possibilities related to the U.S. nuclear fleet, the nation's largest source of zero carbon power. We thank the DOE, Office of Nuclear Energy, again for their support, and we look forward to working with the 3 organizations represented here today as via our panelists, the Nuclear Energy Institute, the Electric Power Research Institute, and the Good Energy Collective, as well as other experts engaged in nuclear research, policy, and regulation to share their perspectives over the course of this partnership. Commissioner Echols, would you like to say a few words of welcome?
Thank you, Commissioner. It is great to have everyone here, and it's so many exciting things happening in our country. Of course, just here in my state, Plant Vogtle Units 3 and 4 in hot functional testing. I met with all of the union heads today, the craft labor involved. They are so excited about finishing this project. It's just going to be a great accomplishment. And of course, many of you heard this week with Secretary Granholm saying that DOE is considering a production tax credit or other incentives to prevent premature nuclear closures. So with that coming out of Washington, it's huge. So Tony, I'm really looking forward to not only today, but our times together as we maybe usher in a nuclear renaissance that we didn't think would happen in the U.S. after the things that have happened in recent years. So I'll turn it back to you to introduce our panel.
Yeah, thank you for those remarks, Tim, and I couldn't agree with you more. It's a potential great opportunity, and it's so nice to be kicking off this partnership with the DOE Office of Nuclear Energy and NARUC. So without further ado, I'm now going to introduce our first panelist, Matthew Crozat. Matt Crozat is the Senior Director for Strategy and Policy Development at the Nuclear Energy Institute. He's responsible for directing NEI efforts to identify policy initiatives that will improve the economic viability of operating plants and enhance prospects for new nuclear developments. Matt examines market operations and proposed policy to assess their impact on nuclear energy. He also oversees analysis of nuclear industry cost performance and trends. Before joining NEI in 2015, Matt was a senior policy advisor in the Office of Nuclear Energy at the U.S. Department of Energy. Matt is recognized as an international expert on nuclear energy and nuclear energy economic issues. He served as co-chair of the Working Party on Nuclear Energy Economics at the Nuclear Energy Agency of the Organization for Economic Cooperation and Development, or OECD, for over 10 years. He holds an MA from Cornell University and a BA from Tulane University. Mr. Crozat, welcome.
Thank you, Commissioner. I appreciate the opportunity. So as Commissioner O'Donnell said, I'm from the Nuclear Energy Institute. And for those who don't know, NEI is the trade association that represents the U.S. nuclear industry. Our members include companies that own and operate nuclear power plants, those that design and build them, service them, and universities and lawyers and a whole range of people who are invested in the nuclear industry. We provide a single voice to engage with governments, policymakers, and the community at large to represent nuclear to these broader communities. Let me go to the next slide. So during my brief remarks, I want to touch on 4 basic themes. The first is a quick overview of nuclear energy in the US. Second, I want to hit on one of the key trends we're seeing right now. And then the third and fourth are to relate to some of the recent events that we're seeing in the news, both in Texas and in Washington. But let me start with where nuclear energy is today. As you can see, majority of the states in the US have some form of nuclear energy. We have 93 reactors at 54 sites. Let's go to the next slide. Those 93 reactors, well, 94 last year, produce almost 20% of electricity in the United States, and it's been at about that rate for over a decade. Let's go to the next slide, 2 decades. Nuclear energy is the largest form of carbon-free electricity in the US, more than doubling wind and more than doubling hydro. Let's go to the next slide. So the nuclear fleet has performed at very high levels, especially over the last 2+ decades, where nuclear plants have operated over 90% of the time for decades on end. No form of technology in the US produces electricity at the same level of efficiency as the nuclear fleet. All that being said, let's go to the next slide. One of the key trends that we've been facing over the last 5 to 10 years has been the threat and realization of premature closures and shutdowns of nuclear plants. Just last week, we closed another plant in New York, in Indian Point Unit 3. In all, we've seen the closure of plants in the Northeast, the Midwest, and even California and Florida over the last decade. We've also seen the announcements of plants that are expected to close, some as soon as this year in Illinois. This has been one of the really driving forces of the industry, is how to ensure these plants that are well run are actually given the incentives to continue to operate. Next slide. We have seen states take the lead on this problem. For as difficult as it's been to see these plants close, the problem would be much worse if not for policymakers in New York, Illinois, Ohio, New Jersey, Pennsylvania, and Connecticut, who have ensured that policies have been put in place to prevent plants that were facing closure from actually taking that step. So let me go to the next slide and say, well, so what's been the challenge here? Well, these plants all operate in markets that have not done a strong enough job in providing the economic signal to say that what nuclear energy provides is being appropriately valued. I'm going to focus on 2 of those characteristics. One is firm generation, and the other is carbon-free electricity. Let's start with the firm challenge. Let's go to the next slide. The need for firm power, I think, was driven home quite starkly earlier this year when we saw the cold weather event that hit Texas, which was truly unexpected by historical norms, but part of the current reality of the changing weather conditions that we're seeing. During that time, we saw widespread power outages hitting almost 4 million people at the height. Let's go to the next slide. So what happened here? Well, with the weather challenges they were seeing and the high demand for electricity, ERCOT, the organization that coordinates power in the most of Texas, didn't have enough electricity in its system to meet all the demand being drawn. And so it ordered that all of the utilities to reduce power output, called shed load. I highlighted the one in the middle here, CenterPoint Energy of Houston. And the reason I highlighted that one is that happens to be where my brother-in-law lives with his wife, my niece, and my mother-in-law. And they were without power for 4 days. And what you can see here is at the height of the problem, Texas had to drop almost 20,000 megawatts of electricity. By way of comparison, that's more than the entire state of New York needs right now, or all of New England for that matter. So this wasn't coming up a little bit short. It was a dramatic failure of the system. Next slide. Now at the heart of this was trying to depend upon electricity that would normally be there under the normal conditions, but was not available in this extreme event. And we saw all kinds of technologies have problems. We saw wind had problems with freezing issues, though honestly, those weren't that dramatic because you weren't expecting a whole lot of wind anyway. You had a little nuclear at the bottom where 1 unit went offline for about 3 days, a little less. We saw a lot of problem with natural gas. And this isn't a huge surprise in the sense that Texas has a lot of natural gas and this electricity system relies heavily on natural gas. But what we ran into in this event was that the capacity that was there might have been available, but the supply of fuel wasn't firm enough. So we had plants that may have been able to run, but the fuel itself wasn't on hand and able to operate the plants. In many cases, those plants themselves weren't weatherized to deal with these kinds of extreme conditions. From a nuclear point of view, the challenges that the natural gas systems faced in Texas aren't the same challenges that a nuclear plant would face. The fuel for those plants, the nuclear plants, are on site. They don't need to be brought in real time. Instead, they're loaded up and ready to go for 18 to 24 months at a time. And so as we look towards future systems that are trying to manage these different kinds of technology portfolios, nuclear has a role in being able to provide that reliable, firm power for those extreme conditions like Texas faced. Go to the next slide, because I want to switch gears a bit on my brief time left, which is, as we've watched in Washington, the conversation around the need for carbon-free electricity has really picked up recently. You see President Biden had the American Jobs Plan with a clean energy standard that included nuclear as part of the technology set, as part of this infrastructure plan moving forward. Part of the support for nuclear, I think, can be connected as well to the strong ties with labor. The International Brotherhood of Electrical Workers president helped to lead the Biden campaign platform on energy and electricity. With this support, we've seen that the administration appreciates that we need nuclear as part of a solution, but we need to get the policies in place that are going to make that translate into the signals that will keep plants operating and provide the incentives for new ones to move forward. Let's go to the next slide. This is consistent with where the utilities themselves are going. There's actually many more names here than you can possibly read, but the ones in blue are NEI members. And these are all utilities that have made commitments to reduce carbon emissions by 2050 in most cases. And what we see is a dramatic plan. These are from the companies themselves, commitments they have made on behalf of their shareholders to reduce carbon emissions. So we're seeing this trend where we have policymakers identifying the need for carbon-free electricity. And we're seeing the companies themselves realizing that this is part of their evolution that they need to reach to get there. And nuclear is part of that. If we get the incentives in place to recognize that these carbon-free values need to be clear to plant owners that they should be valued. My last meaningful slide. Next slide. So this brings to a challenge, which is, as we look towards carbon-free portfolios for electricity generation, we're going to have even less use of the coal and natural gas units that have been part of providing that firm power under most conditions. As we've done the modeling of what these futures look like, that combination of firm generation that's also carbon-free is really valuable. Studies looking at the Pacific Northwest, for example, found that including nuclear can reduce the cost of the system by $8 billion. And so we are creating this opportunity here for a technology like nuclear energy to both provide the reliability the system will need without contributing to carbon emissions. And last slide. And with that, I just come back to this clear picture, which is that nuclear's opportunity as a firm carbon-free technology is something that has great potential as we look forward, but we're going to need to have the policies in place. We have seen states begin that journey and step forward to ensure we don't lose many of our nuclear plants, but that challenge needs to move beyond those handful of states to the broader country. And we're working with our colleagues here in Washington to help make that reality at the national level, but also at the state level as well, which has been where we've seen the leadership to date. With that, thank you. I look forward to the questions. I turn it back to you.
Thank you, Matt. We will have questions for you. Let's bring up our next speaker, and I'll be moderating questions after our final speaker today. But our next presenter is Heather Feldman, and she's the Director of Innovation in Nuclear Sector at EPRI, the Electric Power Research Institute. She leads a team that conducts applied R&D to overcome barriers for modernizing and maximizing the utilization of the existing nuclear fleet and for deploying advanced reactors, which I had a conversation with the unions about today, and I'll talk about that during Q&A. But prior to her current role, Heather was the director of plant support and led an expert team developing new and enhanced technologies and processes for inspection and repair, aging management, flexible operations of nuclear plants. And she previously worked in engineering programs, steam generators, and innovations at EPRI. But before joining EPRI, she worked for the United Space Alliance, where she contributed to the successful return to flight mission after the tragic Columbia accident. Heather is a triple tiger, I guess we should say. She holds both a Bachelor of Science degree in mechanical engineering from Clemson, as well as a master's and a doctorate in mechanical engineering. So welcome, Heather, and could you please just slow your football team down up there?
I don't know about that, but I appreciate that introduction, Commissioner Echols. It's great to be a triple tiger, as you say, and it's great to be here today. I wanted to start and spend just a minute talking about EPRI, the Electric Power Research Institute. We are an independent non-for-profit organization that conducts research and development on the end-to-end electric power system. In the United States, our members generate about 90% of the electricity. And if you narrow that down to the electricity produced by nuclear energy, 100% of the utilities with nuclear assets are our members. What I want to talk about today is a focus on the state of nuclear, the nuclear industry in the United States, and the role of nuclear energy in reducing economy-wide carbon emissions. My remarks are going to reflect the recent pledge made by the Biden administration on greenhouse gas reduction targets, the current state of nuclear power, innovations in nuclear power, and I'll wrap up with a look at the future. Next slide, please. So last week, the Biden administration pledged to reduce U.S. economy-wide carbon emissions to around 50% below the 2000 levels. And we need to achieve this by the 2030 timeframe. So effectively, this is telling us what we need to do and by when we need to make this happen. And this goal amounts to 2 gigaton reduction in annual energy-related carbon emissions by 2030. If we compare what we need to do between now and 2030 with what we did between 2005 and 2020, we'll need to basically triple the rate of carbon reduction. So we have a lot to do over the next 10 years. The pathways to accelerate this affordable, reliable, clean energy transition include energy efficiency, light bulbs, for example, cleaner electricity like nuclear energy, wind, solar, electrification, so moving towards electric vehicles, induction cooking in our kitchens, and then finally, clean energy carriers, so using hydrogen, basically in hard to abate systems like shipping industry, heavy transport industries. And nuclear energy contributes to being a cleaner electricity source, as well as a means to produce clean energy carriers. So we've got a very big goal to achieve in a very short period of time. Next slide, please. Matt touched on some facts about nuclear power, and I'm going to add on to that a little bit here as well. So in the United States, nuclear energy provides over half of the carbon-free electricity generation. And we've made great use of our nuclear power plants by increasing the electricity output through power uprates. Basically, over the last 2 decades, we've used power uprates to maintain nuclear power as about 20% of the overall mix. So we haven't built new plants necessarily, but We've upgraded the existing fleet. That's a great use of the nuclear plant assets. In addition to that, we've also extended the license or renewed the license of the plants. Originally, the plants were licensed for 40 years. About 86 of the reactors are now licensed to operate for 60 years. So 60 became the new 40. Then, and that effort was started in the mid-1990s when the original plants were about 30 years old. But today, I'm excited to share that 80 is now the new 60. So about 10 years ago, EPRI, the Department of Energy, NEI, and many other organizations collaborated to develop a technical basis to enable long-term operations of the reactors out to 80 years. So with that, there's now 6 units in the US that are approved to operate out to 80 years. Most recently, Surrey units 1 and 2 were approved to operate out to 80 years. That happened earlier this week. And in the 2020 edition of the NEI IEA report titled Project Cost of Generating Electricity, it notes that long-term operations is the most cost-effective source of low-carbon electricity. And the notion that I want to leave you with on this slide is the existing fleet of nuclear reactors in the United States forms the backbone of dispatchable carbon-free electricity, and it paves the way for our future. Next slide, please. There's been significant changes to the generation mix over the last 15 years. Wind and solar have basically exploded on the scene. They went from being a very small percentage of the electricity generated to about 9% of the mix today. And this has implications on the grid in terms of matching demand with production. And this is where the infamous California duck curve comes from. That term was coined by the California Independent System Operator in 2012. Local markets in other parts of the country are experiencing similar challenges. So nuclear reactors have adapted to those changing needs. The baseload nuclear plants have become flexible by adjusting electricity output in a coordinated and safe manner. We've conducted research and development to understand and manage the implications to operations and maintenance of the plants. Today, there's probably about 10 units around the country that are operating flexibly. They'll move between 70% power and 100% power for a few hours, for a few days, depending on the need of the local market. In addition to that, research is underway to look at nuclear plants providing frequency control on the grid. This would mean that they would need to change their power by about 7%, so less than what they're doing when they're operating flexibly. And finally, an alternative way to adjust the amount of electricity that goes onto the grid is to keep the reactor at 100% power, but use the excess electricity or steam to produce another commodity or to store the energy. So in the United States and funded by the Department of Energy, there are 3 pilot studies that are looking at using nuclear power plants to produce hydrogen. And that gets towards one of the pathways that I mentioned on the first slide, the clean energy carrier pathway. These pilots are using both low temperature and high temperature electrolyzers using electricity and steam from the plants. And the research that will lead up to these pilots is being conducted by the state-of-the-art Integrated Energy Systems Laboratory that's located at Idaho National Lab. So nuclear power plants are flexible. There's a role that they play in producing electricity as well as energy carriers. Next slide, please. So as we look at what I just talked about, nuclear plants are adapting to the changing needs of the grid. Nuclear plants are being operated for 80 years. For Surrey that I mentioned earlier, this would mean that Surrey units 1 and 2 are operating well into the early 2050s. Innovations are being deployed to modernize the plants, to reduce O&M costs, to make the plants more cost competitive. I've got two examples shown here. The first one is electronic work package. So envision a nuclear power plant that has a wireless system throughout the plant and a worker that has an iPad in hand. That iPad contains the work instructions that they need to go out and do their assigned activities. It contains the procedures that they need in order to do those tasks. So not only is that worker able to get information in a timely manner, we're also collecting data, and that data leads to identifying bottlenecks that can be changed such that we have a more efficient and effective workforce going in. So that's pretty exciting change for us. The second example that I have here is drones. So imagine performing a visual inspection of the containment dome. You can take a high resolution camera, place it in a drone, have the drone fly around containment to gather the needed data. The images can be analyzed using machine vision in a very, very timely manner. That's another exciting innovation that we're seeing deployed at nuclear plants today. So nuclear plants are being modernized. Next slide, please. When I look to the future of nuclear power in the United States, I would say our future is bright. The 93 operating reactors have the option to operate out to 80 years. And that's the most cost-effective source of low carbon electricity. Vogtle units 3 and 4 are the first new reactors built in the United States in more than 3 decades. They are coming online in the next 6 to 12 months. And that project has attracted new investment, supported economic growth, and created jobs in Georgia. There's more than 7,000 workers on site and more than 800 permanent jobs once the units come online. In addition to that, as we move forward in time, small modular reactors and advanced reactors will come online and will be demonstrated starting in the late 2020s going into the 2030s. Specifically the carbon-free power project, which is a NewScale power plant. It will be located at the INL site targeting the late 2020s. Late last year, the Department of Energy launched the Advanced Reactor Demonstration Program with 2 Tier 1 awards going to Natrium, which is a collaboration between TerraPower and GE Hitachi and X-Energy. Natrium's a sodium-cooled fast reactor coupled with a thermal energy system. So coming out of the gate, it's already a flexible system. And then the X-Energy design is XE100, which is a high-temperature gas-cooled reactor that's ideally suited to provide flexible electricity as well as process heat for a variety of industrial applications. So we have pathways to achieve economy-wide carbon-free goals in the 2030, 2050 timeframe that include nuclear power. The existing reactors can operate out to 80 years. They're flexible, and innovations are being deployed to reduce O&M costs. The next generation of reactors is here today with the anticipated commercial operation of Vogtle in the upcoming months and the deployment of small modular reactors and demonstration of advanced reactors in the upcoming years. So the future is bright for nuclear in the United States. And I'm looking forward to our Q&A session, and thank you.
Mr. Chairman, would you like to introduce Jessica?
No, I got it. I was waiting to be unmuted. Thank you, Commissioner. So I'm going to introduce our next panelist, and then Commissioner Echols will be moderating some Q&A following that. So I'm pleased to introduce Jessica Lovering. Jessica Lovering is co-founder of the Good Energy Collective, a new organization working on progressive nuclear policy. She recently completed her PhD in engineering and public policy at Carnegie Mellon University. Congratulations, Jessica. Her dissertation focused on how commercial nuclear trade affects international security standards and how very small nuclear reactors could be deployed at the community level. She is a fellow with the Energy for Growth Hub, looking at how advanced nuclear can be deployed in sub-Saharan Africa. She was formerly the director of the energy program at the Breakthrough Institute, a pioneering research institute changing how people think about energy and the environment. Her work at Breakthrough sought policies to spur innovation in nuclear power technologies, to drive down costs and accelerate deployment as part of a solution to climate change and economic development. Welcome, Ms. Lovering, and we look forward to your presentation.
Thank you, Commissioner. It's a pleasure to be here today. If we go to my first slide. So just really quick, I wanted to say a little bit more about Good Energy Collective because we are quite new. We just were founded last year. So we're specifically focused on progressive policy for nuclear, and that is quite different. We've seen wonderful bipartisan groups supporting nuclear at the policy level in the last 5 to 10 years, and lots of moderate policy, but there's a kind of a big gap that we identified. Progressives have typically been quite opposed to nuclear, so we're building out the case and for nuclear on the left, and also policies that align with this broader climate change agenda. So going to the next slide. As Matt and Heather highlighted, we have all these great advanced reactor technologies. They're starting to go through the licensing process. We're probably going to be building demonstrations in the next few years. That's really exciting. But now we need to think about where the first commercial plants will go, and also the siting process for those, and how to gain social license for these projects, because we've gotten a little out of practice. So next slide. And the reason that we need a new model for siting is because we haven't really sited an entirely new nuclear power plant in several decades. And the old model was quite contentious. So it was the model that utilities used, or vendors used to site nuclear power plants in kind of the 60s and 70s has come to be known as decide, announce, defend. So the decisions were made without a lot of input from local communities, at least in the early stages. So we're looking to develop new models that are really community driven. And this fits better with some of the new nuclear technologies we're seeing, much smaller, that really can be incorporated into the local level. And I wanted to highlight here that I think states can play a really strong role in holistic planning of siting, not just for nuclear, but for new energy structure. Okay, next slide. And I did just want to note that community opposition is not specific to nuclear. We're actually seeing a lot of growing opposition at the local level to large renewables projects and large energy infrastructure in general, like transmission lines. And so it's important that we figure out some new models for engaging with local groups for siting, but I think nuclear is probably going to face some of the strongest headwinds. Okay, next slide. So a little bit of context on where the politics are around climate and energy. We've seen a lot of growing momentum just in the last few years around big climate legislation, things like the Green New Deal. And it looks a lot different than climate legislation we maybe saw 5 or 10 years ago. There's a lot more tying in of ideas of environmental justice, racial justice, so making more of an intersectional climate policy. This was really explicit in Biden's campaign, his climate agenda, and now the American Jobs Act. And if you could click next, there should be some text that pops up. So this is some text from the Biden-Sanders Unity Task Force, their recommendations on climate. And this was really an effort to kind of bridge different factions within the Democratic Party. But this text has really set the stage for how the administration is thinking about nuclear. So I wanted to read it to you. It says, we will advance innovative technologies that create cost-effective pathways for industries to decarbonize, including carbon capture and sequestration that permanently stores greenhouse gases, and advanced nuclear that eliminates risks associated with conventional nuclear technology while ensuring environmental justice and other overburdened communities are protected from increases in cumulative pollution. So it's a strong support for advanced nuclear, but it's not unconditional. It definitely has conditions. And what I'm going to talk through in the rest of my few slides is how to think about these from the nuclear perspective, and also some of the opportunities they provide. It's not just challenges that need to be overcome. So next slide. So something we put out, oh, the text doesn't show up, but is a progressive policy agenda for advanced nuclear. So this is things we were asking for the Congress, the administration, and also industry could do to align some policy on just pulling in more progressive values into nuclear policy. You can read that on our website. I'm not going to dive too much into that, but we have a bunch of recommendations to align those two camps. You want to go to the next slide? Oh, okay. The link, that's the link. But if you go to our website, you'll find it pretty easily. Okay, next slide. Yeah. So what's next? I wanted to highlight two pieces of federal action that I think people should be keeping an eye on as they relate to nuclear. So the first one is Biden's Justice 40 initiative. The second is Clean Electricity Standard. So next slide. So this idea of Justice 40, it used to be called EJ 40, was in Biden's early climate agenda, but it was really laid out recently in the American Jobs Plan. So what Justice 40 does is it requires 40% of the benefit of federal spending on climate and energy go to disadvantaged communities. And that's really broadly defined. It can be groups that are economically disadvantaged, that have a large share of racial minorities, but also communities that have a legacy environmental pollution burden, whether it's from industry or even potentially from federal facilities. And it could also be communities that have that are fossil dependent currently. So we wanted to think a little bit deeper about how nuclear can align with this goal. And so we put out this short memo called A Policy Pathway for Nuclear Justice. And it is really recommendations for the Office of Nuclear Energy on how they can align with this goal of 40% of the benefit going to disadvantaged communities. But I also want you to think, at the state level and from industry perspective, how you can also work to really expand access to the benefits of clean energy and make sure you're not overburdening certain communities with the risks or the harms from energy production. So you can read more from that link. If you want to go to the next slide. We have a lot of recommendations in that report around, making progress on nuclear waste, cleaning up legacy sites, but I did want to highlight some of our recommendations that might be most relevant for the attendees on this call is really thinking about equitable and just deployment of new nuclear. So this is really about expanding access and, of course, the economic benefits of new nuclear because they do have a lot. And what's important here of this focus on justice is we really want to have community-driven adoption. So thinking about looking at potential markets that might be new or different than the large nuclear we built in the past, and how you could start engaging with those communities early or preparing them. So some markets that we talk about, maybe giving them some support is, using SMRs or microreactors for community microgrids. Microreactors in particular could serve critical loads on larger grids. So maybe you have a grid that's integrated into a larger grid, like in a big city, but you have your hospitals, your fire stations, your police stations are on their own microgrid that can be isolated or can be islanded in some emergency and continue to be powered by a microreactor that has a lot of emergency response applications and resiliency impacts. And the last one, just an idea, is coal repowering. So we have a lot of coal plants that are closing around the US in the next 10 years, and that can be really hard on local economies. So thinking about maybe these are good places to site new nuclear, but we need to have start the process now of maybe funding feasibility studies at these communities. What sort of education campaigns or workforce training are needed locally. And of course, there's a lot of regulatory questions regarding this more distributed siting of nuclear technology. And maybe there's community ownership or municipality ownership of much smaller nuclear. That opens up a lot of questions as well. So next slide. I just wanted to give one example of this idea of thinking about siting and where new nuclear could go. This is a quick map I threw together of coal power plants greater than 100 megawatts. So plants that might be a good fit for replacing with an SMR that are retiring basically in the next 10 years after 2020. In states that don't have restrictions on new nuclear. So there's maybe a dozen states that have some sort of restriction on new nuclear. And it would be more challenging to build there, of course. And then the light green states on this map are states that have explicit inclusion of nuclear in their state level RPS, Renewable Portfolio Standard, or Clean Electricity Standard. So there might be some extra benefits of building in those states. So just to think about, there's a lot of different options there, but thinking about community approaches and how you might approach some of these. I know there's been some local interest, like in Montana, there's a state level feasibility study of replacing coal with SMRs. So we might see more action at the state level around this. Okay, next slide. This is my last substantive slide. So something the Biden campaign really focused on this target of fully decarbonizing the power sector by 2035. And he made this goal explicit in the American Jobs Plan and called on Congress to introduce a clean electricity standard to implement that goal federally. And if you're not familiar, so a lot of states in the US, I think 31 states have renewable portfolio standards, which mandate a certain amount of electricity comes from renewables by a certain date. And there's been federal clean electricity standards introduced many times, but this is the first time we've seen a lot of momentum from both the executive branch and Congress in alignment. So in March, House Democrats introduced the Clean Future Act, which would require that all electricity providers get 80% of their generation from zero emission sources by 2030 and 100% by 2035. So that's very ambitious. We don't know if this will pass or if it will be that ambitious when it finally does. But it's very important to note that it explicitly includes nuclear along with carbon capture and sequestration, large hydro, direct air capture, geothermal. It's very technology inclusive, which I think is important. And the way it's written now, it could benefit existing nuclear plants and incentivize new nuclear. So I just wanted to put this on people's radar, if it's not already, that it's really important for state regulators to start thinking about long-term integrated planning. It's not just about, balancing renewables with natural gas. There might be stronger targets coming down the line or mandates that that state level agencies will need to start thinking about and incorporating into their planning. So I think that's my last slide. If you want to go to the next slide, and look forward to answering questions. Thank you.
Fantastic. And I just followed you on Twitter, along with a number of your other folks. You got some good stuff out there. So wonderful to have you on Twitter there. So, hey, look at what we've learned so far, that conditional love, a plus, to our industry, that 60 is the new 40, and that firm is the best four-letter word you're going to hear today. So audience, you can submit questions by clicking the Q&A. I mean, we've got 14 minutes. We'll do our best, and we'll get to as many of your questions. Panelists, feel free to respond in the Q&A. You can multitask, right? And panelists, this is a lightning round, so keep your answers short. Jessica, let me start with you, my Twitter buddy. In thinking about the Justice 40 initiative you mentioned from the president, I recently talked with both the mayor of Waynesboro, the county chairman of Burke County, and the sheriff of Burke County around Plant Vogtle. They're all African-American leaders. They're all uber fans of Plant Vogtle and how that tax revenue has built them new schools and roads and libraries and ball fields and just improved their quality of life. How can our industry help tell their story in light of the Justice 40 initiative and get that story out to a larger audience?
Yeah, so I think, Matt touched on this and maybe Heather did as well, but nuclear plants definitely employ a lot of people. They pay much more than other types of power plants. They're much more likely to be union jobs. So I think, that's a big reason why Biden has been such a strong supporter of nuclear, and it's important to get that message out there. Something a little less well known is that today our large nuclear power plants tend to be located in wealthier, whiter suburban areas, whereas fuel cycle facilities tend to be located in lower income and communities of color. So when we're talking about how nuclear can align with the Justice 40 initiative, it's really about expanding the opportunities of those benefits for nuclear. So, it's great that you have that local support for Vogtle, and we'd love to see that go into more places and more different kinds of communities that maybe haven't had nuclear in the past.
Okay, good. Well, for years now, I've asked groups whether they thought that Fukushima or cheap gas had the greatest chilling effect on the nuclear renaissance in America. And to the group, they always said cheap gas. But I think the Texas crisis has showed us that if gas isn't cheap and firm, systems are at risk. So let me start with either Dr. Feldman or Matt. What have we learned about the role of nuclear in winter storms and polar vortexes? And keep your answers brief.
I'll keep it brief because that's a seminar question. So what we've learned is the natural gas systems that we've expanded greatly with the influx of fracked natural gas, they weren't really designed to be these winter power plant fueling systems. They were designed to bring natural gas to heat homes. And so in the summertime, this works great because that natural gas isn't being used to heat homes. So when I need to run my air conditioner in August, I can use natural gas. These winter storms, though, are challenged because that gas goes first to heating. So if I'm relying on that fuel to be there when I need to have electricity demands that are being challenged, I might have a hard time finding enough natural gas available. And that's where nuclear is valuable because I don't need to have that fuel coming in real time. I've already got it there.
Okay, let me ask Dr. Feldman. You don't have to say the same thing. Anything you want to add to that?
I was going to comment from a nuclear plant side in that, nuclear plants are resilient through these types of storms. Matt did note that one of the plants in Texas was offline during the most recent event, and that was a result of some lines getting too cold. So even though nuclear power plants are resilient, they also need to be winterized.
Thank you for that. Jessica mentioned citing nuclear at existing fossil plant sites. I mean, just today, this morning, I had breakfast with IBEW, the buildings and trade unions, the sheet metal guys, the pipe fitters, and others about the idea of building advanced nuclear here in Georgia as we retire fossil plants, in particular coal plants. So to any of you, we'll start with Jessica, since I mentioned her, which advanced nuclear technology seems the most promising in the current federal policy landscape?
Ooh, I don't want to pick winners. I think we have a diversity of new designs coming through the licensing process, but I will say that NewScale, which is a light water reactor, small modular reactor, has been specifically pushing this idea of repowering coal plants. And so really anything could probably be a good fit. But one of the advantages of using an existing site like a coal plant is they have access to those transmission lines, maybe water resources, and it's a brownfield site, so it makes it a little easier for that approval. So I think it's something that a lot of these vendors should be looking at.
Okay, sorry, I'm just going to move y'all on quickly so that we can hear from everybody. Matt, let me go to you on that. Which do you favor a technology?
I favor whichever one's going to get built first and have as many as possible. But what I will say is, Jessica mentioned the availability for transmission and cooling water, and those are true and they're great, but also the workforce. One of the points that my boss, Maria Korsnick, makes is that she used to run nuclear power plants. And when they would have outages, it would be folks from the fossil plants that would come help work on the nuclear plants. So a lot of those jobs are the same kinds of jobs. And so trying to find that pathway to say, for these communities who might be in this position of seeing one part of their economy with a shorter time horizon, well, how do we build that pathway to these new ones? And we're trying to engage those same stakeholders you are. We've got a lot of excitement and enthusiasm on Capitol Hill and with others. So we think there's a real opportunity here and we'd like to explore it. And
to Dr. Feldman, you have a favorite?
I do not have a favorite other than, fastest one to the finish line. It's a great opportunity.
Well, great. We've spent $49 million in citing what would have been an AP 1000 at Stewart County, another poor African-American community south of Fort Benning. And we could take any of those technologies, as you mentioned, NewScale or anybody else. So we're watching very closely on that too. Okay, let's go to our next question. So I mentioned up front that Secretary Granholm spoke yesterday about the possibility of a DOE production tax credit or other incentive to prevent the premature closure. I'll start with Matt on this. Matt, you had to be excited to hear that.
Or you can only imagine. Having been at DOE as this problem began to really materialize, I came to NEI because I thought this was a more likely place to be able to tackle this problem of closing well-run nuclear plants. So to see DOE and the administration and members of Congress looking for solutions, which honestly the states have been leading the way on this for years, I'm glad to see Washington coming around, and boy, we look forward to seeing this go from a positive signal to an actual policy.
Yeah, let's go to Dr. Feldman. How about your reaction this week?
Yeah, my reaction, I immediately thought about conversations that I've had with chief nuclear officers that will say, if we can level the playing field, I can compete. So I was pretty excited about it.
Yes, Jessica.
Yeah, same here. I think keeping those plants open is sort of something everyone can agree on.
Yeah, and you tweeted about it, so we got to give you extra credit for that. So, and when President Biden flies Air Force One into Augusta, Georgia, and does the wrench turning at Plant Vogtle, that is going to send just a shockwave through the nation and just accentuate everything that he's been talking about. Let's go to another question. You guys are doing really good, by the way. Congratulations on how you're going through this. So let me ask you about flexibility. How flexible is nuclear when it comes to balancing energy? Is it more accurate to describe nuclear as baseload or as a dispatchable resource? And I'm going to start with Dr. Feldman on this.
Yeah, I can elaborate on some of the comments that I made in the presentation. So, a nuclear plant, for it to operate flexibly, it has to be coordinated with the grid operator. So it's not like the grid operator can say, okay, I want to take you from 100% power down to 70% power. It needs to be coordinated. It's controlled and done at the plant by a senior reactor operator. So the potential is there for the plant to operate flexibly. It just needs to be done in a coordinated way.
I'm going to I'm going to exercise a co-chair privilege here, jump to a audience question because we only have about 4 minutes left. So a panelist asked, and a person asked, does the panel have views on molten salt storage with nuclear? A lot of these new plants are being designed with storage to have that flexibility to ramp up like peakers to support wind and solar. And I'll just have whoever wants to hop in very quickly on this.
Yeah, I just wanted to echo Heather's comment that, nuclear plants, the main reason they don't load follow now is economic. They want to run as much as possible, but new designs that incorporate storage like molten salt storage could offer more peaking capability or flexibility in an economic way, and that has huge value to grid operators. Something I've seen, I did modeling of microreactors on microgrids, is that if batteries are cheap enough to be backup for renewables, they can also be very valuable for nuclear power plants and sort of triaging costs, or when to sell and when to charge the battery.
Other panelists want to chime in on this one?
Sure. I mean, I'll just tie these last two questions together a little bit, which is that we have a class of designs that are being developed now with the intent of meeting the challenges of the grid that we're going to be working towards. We'll have more intermittent sources, more needs to change power levels. We also need to create the markets that are valuing those things correctly. Right now, as Jessica said, there's no one that values the idea that you can turn yourself down. And so we need to bring along not just the technology, but the rules in which they're being used as well. And the regulators at the state level are an important voice in that process.
Let me jump to Dr. Feldman on this question in the Q&A. They commented on the labor of the Vogtle reactors taking a decade to build. Is the highly specialized nuclear construction industry able to absorb the magnitude and construction necessary in this short time horizon for these targets that the president has set, 2030, 2035? What do you think?
Yeah, so for us to get where we are today to the 2030, 2035 timeframe, there's not the opportunity for a tremendous amount of new nuclear to come online beyond Vogtle 3 and 4. So we have the opportunity to really build out the supply chain, train, educate, build out the workforce. So we've got a great opportunity in front of us to really plan for and achieve a really big goal.
Well, I wish we had more time to answer all these questions. I could just sit here with you guys all day. You just have done such a great job. I'm going to turn it back to my distinguished co-chair to wrap it up.
Thank you, Commissioner Echols. And what an exciting panel. You all did a nice job. Commissioner Echols, good job for moderating the Q&A, and to our panelists. Wow, very impressed. So thank you, Jessica and Heather and Matt, for your time today, and the Department of Energy Office of Nuclear Energy for supporting this webinar. Please join the Nuclear Energy Partnership for a webinar on advanced nuclear technologies on Friday, June 4th at 2 p.m. Eastern Time. If you registered for today's webinar, NARUC will include you on the invitations for future webinars. We look forward to an exciting partnership with so many more activities to come in this arena, and we hope we grow our ranks and really get some good education going for our members in the states. So check NARUC's website for information on upcoming activities, and please reach out to Kara Zettelman and Jasmine McAdams at NARUC with any questions or feedback. Thank you all for attending today.
Yeah, thank you, everyone.
Thanks, everyone. Have a great weekend.
Take care.